guys, we're going to go to our next talk now. So the next talk will be by Nihan Yami of SAS. So her talk is going to be on analytics for RevOps, model factory approach. So Nihan Yami is a data scientist at SAS, where she builds AI-driven solutions for the revenue operations team. She has over 5 years experience at SAS. She supports clients across industries in applying analytics and machine learning. She holds certifications in AI and ML from SAS and AWS, and has a degree in management information systems. So if you can put your hands together for Nihan.
Thank you. Thank you so much for joining this session, and welcome all. This is Nihan Yami, and we will talk about machine learning, operations in general. When we think about data science, we tend to think that it's generally all about models. But this is the tip of the iceberg. Underneath the surface, we have lots of other operations that we need to deal with, like transforming features, deployment, monitoring, testing, documentation, and everything. And today, we will dive deeper to talk about all these different components. Thank you so much again for the lovely introduction. Let me briefly talk about myself. Nihan Yami. I'm working as a data scientist for SAS Institute over 5 years, and you might have heard about SAS. It's an analytics company. We provide analytics solutions to different industries across the globe. And if you'd like to talk about data science, machine learning after the session, I am always happy to have a conversation. You can always find me on LinkedIn, or feel free to send an email to me if you like to have any kind of conversations regarding these topics. Regarding today's agenda, I plan to talk a little bit about the data science, project management approaches, and the challenges that we generally see. And I'll talk a little bit about the MLOps concept. Then the main focus will be around the model factory concept. I will list the key components of it, and I will share some real-world examples, because we have a model factory project that we are currently working on, and I thought it might be interesting to share. Regarding the team that I'm working on, I am working as a data scientist on the revenue operations team. And what this team does is it brings together different teams, like the marketing team, sales teams, finance, customer success teams together under one unified strategy to make sure that we are driving consistent revenue. So this is the idea of revenue operations team. And what we do is this kind of structure introduces enormous amount of data coming from different systems, like ERP systems, CRM systems, and customer success platforms. And as the analytics workforce under revenue operations team, what we are trying to achieve here is we try to make sure that we bring all the data together, we share where it matters, and we make sure that this data decision-making process is supported by the data. This is what we are trying to achieve. And in order to do this, obviously, we need to follow some certain methodologies. And I would like to mention here this CRISP-DM methodology. This is probably the most well-known frameworks when it comes to data science project management. And it consists of some key steps like business understanding, followed by data understanding, data preparation, modeling, evaluation, and deployment. I'm sure most of you are already familiar with it. And this framework would work perfectly for smaller size projects or in more isolated environments like POC environments, for example. But in real world, things can be a little bit more chaotic. And I would like to mention a little bit about the challenges that we typically face when it comes to data science projects. And I would like to start with the deployment challenges. You might have some team members deploying via Jupyter Notebooks. The other team members might export their predictions to Excel worksheets, and they might be just sharing their results through emails manually. And in that case, there's really no automation, no consistency, and it's almost impossible to even trace where the predictions come from. So this is a challenge for sure. And the other challenge that I would like to mention is regarding the monitoring area. most of the times, monitoring is just absent. Some data scientists might think that they build the models, they deploy them, and they're done. But this shouldn't be the case, because we should make sure that the models are still healthy and relevant to the actual business. And we make sure that we are taking proactive approaches before the business even starts complaining about the insights that we are providing to them. And the other challenge that I would like to mention is regarding reusability. Teams reinvent the wheel each time. And they have to write the ETL code that has already been written by somebody else. They have to just find ways to write the same code again and again. So this happens because most of the times there's really no shared logic that lets people to collaborate efficiently. And the other challenge I would like to mention is regarding the scalability. Managing 5 models might be relatively easier, but some organizations have more than 100 models, right? So if this is the case, all of a sudden, you would start seeing lots of different pipelines all over, different requirements, different documentations. And this is a recipe for a technical debt. And the worst part regarding all these challenges, they're not only technical challenges, they directly impact the business. What I mean is, for example, if the data science projects are not fast enough to support the business, then in that case, you cannot really came up with right solutions in the right time, right? Or maybe the business lost trust in the data in the background, so you're just really not supporting them because they will be avoiding making decisions based on the data. And different people all over, different teams were experiencing those challenges, and they were looking for ways to make the data science project management in a more efficient and repeatable ways. And this is where the idea of MLOps came in. MLOps is the discipline of managing the entire machine learning life cycle, and it really brings a structure on how to develop, deploy, manage, and monitor the data sets or the data. And the idea of MLOps really came from DevOps. And DevOps is another discipline that revolutionized the way that we release software. It introduced concepts like automation, collaboration, continuous integrity, continuous delivery. And in essence, the idea of MLOps is really similar with DevOps, but we have some differences as well. In software development, we deploy code. That's why the real focus is around code versioning. In data science, we deploy models that rely on data and data changes. That's why, in addition to code versioning, we also have to take care of data versioning, model versioning, and this added complexity makes MLOps a distinct discipline on its own. And here I would like to list some areas that MLOps impacts business directly. I'd like to mention about the scalability aspect a little bit. It is easier to go bigger when you apply MLOps because essentially we support reusability, which we'll talk more in detail in the upcoming slides. And also, it helps build trust because we monitor the result constantly and we make sure that they are still relevant in real world. And it fosters collaboration because we created shared logic that helps people to share ideas. It accelerates time to value because we focus on automation. And finally, it enables compliance because we focus on documentation and versioning control. And you might be asking at this point, okay, this all sounds good, cool, but how do we actually take action? How do we apply all these ideas into real-world scenarios? And this is the answer to this question would be building a model factory. And Model Factory is actually bringing together all the principles of MLOps together in an industrialized setup. And this really is a standardized and centralized system that helps us move from building one-off models to managing the continuous workflow of machine learning solutions. And Model Factory is really similar to real-world factories because the focus is around to be more efficient, repeatable, and the focus is, again, around quality at scale. And the Model Factory is actually a sign of maturity in organizations' AI journey because it helps us scale up while still maintaining the speed and control. In order to build a Model Factory, you need the right components in place. And here I listed the three main building blocks of a Model Factory. A feature store, it centralizes feature definitions across models and teams. AutoML automates the model development process, and the continuous monitoring. So we have three different building blocks. And in continuous monitoring, we make sure that the models are reliable post-deployment process. Well, in revenue operations team, our analytics initiatives are growing, and it becomes more and more complex. That's why we recently started building a Model Factory in our team, and this is a project that I will share more details about. Although our Model Factory is still ongoing, I thought I could still share some screens from our project and give you some thinking processes that we have already went through. What I will do is I will give you more detailed information and explanations regarding each step, and let's start from the feature store one. A feature store. Before talking about a feature store, let's talk about the feature itself. A feature is a signal input in machine learning context that helps machine learning algorithms to make predictions. And in RevOps context, it can be anything that indicates a customer's behavior or sales trends, for example. And the question here is, how do we manage the features at scale, especially when we have multiple models and multiple teams involved? And the answer would be is creating a feature store. A feature store, like in a real factory, is our inventory system because it's a centralized hub where features are stored, versioned, and reused across different teams. There are both similarities and differences between a traditional data warehouse and an MLOps feature store. In a traditional data warehouse, we feed BI tools with data. And storing the data is just one step. It's obviously valuable, but the real value in data science projects lies in processing the raw data in a way that they are meaningful to machine learning algorithms. And this is the essence of feature engineering. Feature engineering involves steps like imputation, for example, where we deal with the missingness. There are lots of other tasks that you can perform, like filtering, for example, outlier handling, normalization, joining, binning. And this is just a brief list that I have put here. There are lots of other tasks that you can perform. And a feature store is really valuable from that perspective because it automates and scales these processes, all these manual processes, making high-quality features reusable across different teams and use cases. Because once a feature is registered, it becomes instantly reusable, reducing redundant work and accelerating future ML projects. This is a simplified architecture on our Model Factory project that we are building for revenue operations team. You will notice that we have the three components here: feature store, AutoML process, and continuous monitoring part. Since we are talking about the future store, I will focus on this part. And what I would like you to notice here is we have different data sources, which I will give more information about. And using these data sources, we built 4 data sets. 2 different granularities, person granularity and account granularity, and 2 different types of data sets, observation data sets, training data sets. I would like to focus on the different granularity levels at this moment. We needed 2 different granularity levels for our projects because we had obviously different use cases. What I mean is, for example, regarding the person level granularity, we used this kind of data set for in a model where we called expansion model, for example. What we do with this expansion model is we identify individual people, individual users within our existing customer base where they have high signals of potential upsell, cross-sell, and expansion. What I mean is, for example, let's say we have a user having a predictive model license, and this person is making predictive models, right? But if this person creates tech support tickets to ask about the text analytics solutions that we also offer, for example, or if this person attends webinars regarding text analytics related products, we have to identify this person and we have to offer upsell and cross-sell opportunities. And this is where we use this expansion model. And this is why we needed person-level data. The reason that we needed account-level data, we use this data for several different use cases, but one example that I can share at this moment is a segmentation model where we use it for our marketing-related campaigns, for example. And let me talk a little bit about the data sources we have. We mainly have 2 different data sources, the third-party data and the internal data. The third-party data is a data set that we purchased from a data vendor, and I think this is interesting because it has different components like the intent score. And this intent score is an expert score where it indicates the customer's willingness to purchase a certain product. And I think this is really interesting. The other components of this third-party data that we purchased is competitors, firmographics. This is also an interesting one where it characterizes the selected organization. For example, it gives insights about the organization's number of employees or the headquarter location of it, for example. Everything regarding the selected organization goes into here. We also have data where to indicate the spend amount of a specific area of a selected customer. And we also have data about their cloud readiness, their footprint with us, and this is coming from the third-party data. And regarding the internal data, we have our marketing engagement data sets, our account, tech support data sets. This is also an interesting one, the tech support data set, because we don't only have the complaints coming from the customers, but we also have the questions coming from the customers, or like everything that, like all the ways that they're interacting with us, they're stored under this tech support data set. We also have renewables, risks, cancellations, opportunities data sets available to our revenue operations team. And this is even a more detailed picture of what we have in our feature store. This flow might look a little bit complicated at the first glance, but I will try to simplify it. By the way, this is still a summarized flow of what we have in our feature store. We have lots of ETL processes that we applied, but hopefully this flow will help me to explain what we have in a sense. You will see that we have two different granularities, the person granularity and account granularity at the bottom. You know now why we have these two different granularities. What I would like you to mention is the two different types of data sets, the observation data set and the training data set. The reason that we use the observation data sets is for the scoring processes. After we build the models, in order to build predictions, we have the observation data sets, and we score our models on a monthly basis. That's why we need to refresh our observation data sets on a monthly basis. We have a scheduled process to create this observation data set on a monthly basis, so it's an automated process. We don't have to worry about it each time. And when we create the observation data set, we can also create the training data set, merging the observation data set with the outcome data set. The reason that we create the training data set is for obviously the training purposes and also for retraining purposes if we need to. After creating this observation data set, it goes into the scoring data sets, and we score it with our models. And the process actually starts with the person granularity side. We do the person granularity scoring, and this scoring process, the output coming from this data set, then goes into the account granularity, where we use them in our observation data set creation. So these two different granularities are connected, actually. And you will see that we have 3 models in our current model factory right now, and you might think that we wouldn't be really needing the whole future the whole model factory project created for these 3 models, right? But in our team, we have the vision to create lots of other models as well. And the idea of model factory is really to be an investment for the future ML project. So it might be, if you're thinking about creating a model factory, it might be good to consider your midterm and long-term goals within your organizations, because this is a lot of effort, obviously. So this project would be more meaningful and valuable if you plan to deliver lots of models. And what I would like to show you here is some example screens from our ETL processes when we need to perform when we build the feature store. And you see we have an ETL process here. And the important point I would like to mention here is make sure, not only for your models, but also for your data creation, make sure that you have versioning control in place. In our projects, we use GitHub, seamlessly integrated to our ETL processes, so we can control everything. This is extremely important because sometimes you need to hand over the code to somebody else. Sometimes you have to refer back to what you have previously done. So this is essential. Make sure that you have your versioning control in place. And let's talk about the second component of the model factory, the AutoML. In traditional machine learning, what we do is we select our business problem, and depending on our business problem, we have to select the model that we plan to run. And depending on the model, we have to come up with different hyperparameters, right? For example, let's say we are building a neural network, and we have to select the learning rate or the number of layers. And the way that we would do with traditional method to come up with the hyperparameter values is we set some values, we run the model with the values that we run. We look at the performance. We again assign new values to the hyperparameters. We run the model, so we compare. So it's like a trial and error process, right? This is tedious. This is time-consuming, and let's call this hand-cranking way. The good news here is that we can always optimize some parts of this process, and we can run a hyperparameter optimization algorithm to help us come up with the set of hyperparameter values. What it does is, depending on the search range that we would identify before running the hyperparameter optimization algorithm, it came up with the best set of combinations of hyperparameter values that would maximize our model's performance. And we can even automate further, and we can automate the model selection process with the AutoML algorithms, where it helps us to select which model to run. In that case, we wouldn't worry about whether we would run a decision tree or a logistic regression, for example, because it will be selected for us. And I think this methodology is good to start with any kind of projects, pretty much, because it's fast. Like, it helps us to come up with results super quickly, and we can always customize our models depending on our needs. In revenue operations, our vision is to be more data-driven for each stage of the sales process, starting from the prospecting through closing and after sales when we do customer success-related performance. And this kind of methodology really helps us focus on the right accounts with the right strategy and optimize our limited customer success and account management workforce, and ultimately coming up with a higher revenue. So this is our vision. And to work on this vision, we have a list of models that we plan to deliver in our upcoming quarters. And you can read the list. But to give you some examples, we have models that we plan to deliver, such as the propensity to create an opportunity, for example, predictive onboarding score, expansion score for services opportunities, cancellations model. I will talk more about this cancellations model. Cancellations model predicts the likelihood of software cancellations based on the interactions of the tech support. And in order to create this model, we needed to use the tech support data and cancellations data to feed our feature store. In order to create the feature store, we had to come up with some feature engineering. We had to apply some filtering to exclude irrelevant records, for example. We had to make sure that our data set is on account level. This is the uniqueness level that we need for this use case. And we had to come up with some new variables where we apply feature engineering based on the number of tickets. So we created new variables like trend variables for different time windows, for rolling 3 months, for rolling 6 months, for example. And the beauty of this structure is these new variables that we have created for this model can then be used for different models. For example, for customer lifetime value forecasting model is another model that we have in our pipeline. And we don't have to worry too much about enhancing the training data for this model, because we will be using what we have already created for this cancellations models. Okay, so it was this feature store process. And this model is run on an AutoML way, and we predicted some results. And these results were then used in a marketing campaign. originally, how this campaign worked was all the customers were eligible for this campaign, and we had our agents. They were calling the customers just to understand their adoption process, just to make sure how they are doing with our products in general. And how we enhanced this marketing campaign was we handed over the agents a list of customers with the high cancellation risks so that they could actually prioritize which customers to call rather than randomly selecting any customers. And by this way, they could protect the renewals and mitigate the cancellation risk. And again, here are some examples of how we run the AutoML algorithms. You see a pipeline that was automatically generated. And you will see some nodes for the for preparation of the data. You see different models. You see an ensemble model, for example. They're all created automatically. And the beauty of this pipeline is you can always select the node, and you can always change its hyperparameters. You can always tweak the pipeline itself. But this is a great way to start with. And another point I would like to mention is after creating the models, it's always to store them in a centralized repository. And what we do is we build the models and we register them to our model repository. It's important, I think, because whether you build AutoML models or your users might be SAS users, for example, where they write SAS code, or they might be preferring the open source technologies to build models, for example. But regardless of the interface they use, it's always a good idea to register the models so they can effectively collaborate if they need to. And the last component of this model factory is the continuous monitoring. And let me briefly talk about the basic terminology when it comes to model monitoring. And let me explain what a drift is. Drift is a terminology that we use in machine learning to express that the model's performance might degrade over time in production environments. And generally, we have two different types of drift. The data drift happens when the distribution of the data shifts. For example, in our training data set, we might have 16 to 14 years old people, right? But in real world, we might be exposed to broader demographics, and this might affect the model's performance. And the other kind of drift is the concept drift, where it occurs when the relationship between the input features and the target variables change. For example, in our training process, we might have a linear relationship between the targets and the input variable and the target, sorry, but it might turn out to be nonlinear. And after we detect the drift, the next step is to respond to it, and this is where it comes the retraining concept. And to set the stage, imagine that you are graduated from school and you have never ever read another book again. And in a couple of years, would you say that you could still do any kind of decision making in a meaningful way? I don't think that it would be the case, right? Because we have to update ourselves, actually, and this is relevant to machines itself as well. It wouldn't be fair to expect machines to make informed decisions after a long period of time passes after their training process. We have to provide them with the updated data sets. Because in the world changes, the customers' behaviors change, and we have to we have to give the most recent information to our machines to make relevant decisions. In order to respond to drift, we can follow different methodologies. For example, we can do periodic retraining, where we retrain the models on some certain frequencies. It's easy to automate, and it provides consistency, so this is why this method is good. But you might be retraining too early, wasting resources, and you might be retraining too late, and in that case, the performance will have already been dropped. So there is another method that you can follow, trigger-based retraining, where you retrain your models based on some certain alerts. This is more efficient, but it relies on strong monitoring in place. And what I would like to mention here is, in order to do the monitoring, you obviously need to first select the champion and challenger models after you register your models. And you can select the champion and challenger models based on some default KPIs, so it can be selected automatically. But at the same time, you can always go ahead and change which model is champion or challenger for you. After selecting the champion model, the next step is to do the scoring, where you predict the results based on unseen data. In our model factory, we automated the scoring dataset creation process, as I have briefly mentioned when I talk about that part of our project. We haven't automated the scoring process itself, which is an improvement point for our model factory project. And this is the last screen that I would like to show regarding our model factory. This is just an example screen of how you can do model monitoring. You see here some essential metrics like the ROC curve, cumulative lift, lift itself. And this kind of dashboard is important to understand when you would need to do retraining. Again, I would like to mention that you can automate the retraining process, triggering it based on some certain benchmarks, for example. Again, we have the structure to retrain in our current model factory, but we haven't automated it yet. This is one of our next steps to automate the retraining process as well, so we don't have to worry about starting the retraining process itself, because right now we have to start the initiative manually, but this shouldn't be the case in our vision. So this is just one improvement point. And just to wrap up, Model Factory is really not about building higher performance algorithms. It's about building a system that helps you run all the components faster in a more efficient way. Thank you so much for listening, and I would like to take any questions if anyone has. If not, again, feel free to find me on different platforms, and we can always have a chat about all these different topics. Thank you so much.
Great. Do we have any questions? Yeah.
Thank you for the talk. That was really interesting.
Thank you.
Kind of a general question. You know, you mentioned you have like calendar-based and trigger-based kind of retraining of models.
Yeah.
I mean, is it kind of like, I guess it's a sense of like you have a calendar-based training anyway, which is automated, scheduled, and then you could put actually trigger-based on top of that to see how that kind of performs against the recent trends. Or is there like other best practices that you'd recommend for that?
Yeah. Right now, what we do is we go on a scheduled base, so we retrain our models on a monthly basis. The reason that we do is because our the renewals processes and the cancellations processes can change on a monthly basis in our structure. That's why the monthly processes would be helpful in our case, but I would say it would be better to look at the model performances and maybe retrain the models or score the models on a bi-weekly basis, right? So it would be, I think it would depend on the use case, but at the same time, it would depend on what is available in your current capabilities, I guess. So it's always better to do it on a scheduled base or maybe on different phases. So it depends, I would say. Yeah. Thank you. Thank you for the question.
Anyone else?
For the cancellation model,
yeah.
When you're retraining it, or when you're training it in the first instance, are you letting some customers lapse or cancel in order to validate the model?
Mm-hmm. Yeah, yeah. What we do is actually we had to. In that case, we didn't retrain our model. We had to rebuild our model. So it was a process that we started from scratch, I would say. So I think I couldn't answer your question from this model itself because we didn't retrain it at all. The reason that we have to rebuild that model is because the whole underlying data has changed after a certain period of time that we built the first version of the model. We used to use an expert score that was created based on the tech support data. It was like a health score calculated based on different metrics, but then the underlying infrastructure changed and everything, so the people that used to provide that kind of metric, they no longer provide that metric to us, and that's why we had to come up with all these feature engineering for us. So we created a second version of this model with our own new variables, if that makes sense. Does this kind of answer your question? Or
yeah, it does, thank you. And then for I think you said you provided a list to agents to do the outreach campaign.
Correct, yeah.
What format do you provide that in? And do you follow up with them to see how they've actioned it and what the impact has been?
Yeah, great question. Yeah. To answer the first half of your question, we try to make our output as simple as possible. So I am the person providing that output actually to the agents. And what I do is I came up with the probabilities for each account, right? And what I do is I bin those predictions to 3 different bins to indicate the low probability, medium probability, high probability. So they literally have an Excel sheet with customer names and their probability. And in that way, they can just focus on the high probability ones. So this is the answer for the first half of your question. Regarding the second half, yeah, we do have some sort of a comparison methodology where we look at the previous results of how many customers were saved before we apply the cancellations model to this outreach campaign, and we compare the current results. So we have some sort of a comparison methodology to give us an idea of how the model impacted the marketing campaign. Thank you so much for these questions.
Anyone else? No? Cool. Yeah, so thank you so much.
Thank you.
Thank you.
Thank you.